Welcome to the HRS online training series. This training segment covers the mechanics and application of an HRS subsurface intrusion component evaluation. The purpose of this module is to present the basic structure of the subsurface intrusion component, also referred to as the SSI component, and to set the stage for the subsequent modules. Specifically in Module 1, we will define subsurface intrusion for HRS purposes, explain the scoring areas associated with the SSI component, those being areas of observed exposure and areas of subsurface contamination, and finally, provide an overview of how sites are scored using the SSI component. So what is subsurface intrusion? The HRS defines subsurface intrusion as the migration of hazardous substances, pollutants, or contaminants from the subsurface environment into overlying structures. The SSI component allows for the evaluation of two modes of subsurface intrusion, via vapor intrusion and via groundwater intrusion. Let's look at each individually. Vapor intrusion refers to the migration of hazardous vapors from the subsurface environment into overlying regularly occupied structures and is the most common form of subsurface intrusion. Preferential pathways such as cracks in the foundation, unsealed crawl spaces, sumps, or utility lines can make structures overlying subsurface contamination more susceptible to vapor intrusion. The second form of subsurface intrusion is groundwater intrusion, which involves contaminated groundwater intruding into a regularly occupied structure due to a rising water table. Depending on the hazardous substance and its chemical properties, the intruded contaminated groundwater can either release toxic vapors into the structure or deposit particulates that remain behind once the groundwater has receded. Okay, now that we understand how subsurface contamination can migrate into a structure, let's look at it in the larger context of an SSI site. A conceptual site model for a given media or pathway will identify the key aspects of the site. Understanding a conceptual site model is critical when evaluating your site for HRS purposes. A complete conceptual site model for the SSI component will identify the hazardous substances present at the site and their origin. It will also identify how the hazardous substances migrated from the origin into and within the subsurface, and how they then migrated from the subsurface into overlying structures. In the example presented here, the subsurface contamination consisted of trichloroethylene, or TCE, that has leaked from an above-ground storage tank and has seeped into the groundwater. Once in the groundwater, the contamination became part of the groundwater flow and spread beneath a nearby neighborhood. The contamination volatilized into the unsaturated soils above the water table, where some of it then migrated into the overlying homes. Now that we have the bigger picture of how subsurface intrusion can occur, we can now look at how it fits within the HRS structure. SSI is one of two components in the soil exposure and subsurface intrusion pathway, also known as SsI for short. Soil exposure is the other component within the SsI pathway. The SSI component was designed to be evaluated using the same three factor categories used to evaluate the other pathways and components, which include the likelihood of release or exposure, waste characteristics, and targets. Now let's look more in depth at the factor categories. The first factor category we'll discuss is the likelihood of exposure. This evaluation considers whether anyone is actually exposed or could be exposed to the subsurface intrusion contamination. The resulting factor category value is assigned based on one of these scenarios. Like in the other HRS pathways, the waste characteristics factor category in the SSI component evaluates how toxic a hazardous substance is and the amount present. However, the SSI component also considers how likely it is that a hazardous substance is to degrade before intruding into an overlying structure. The targets factor category evaluates who is actually exposed or who might be exposed to hazardous substances intruding into overlying structures. In the SSI component, regularly occupied structures represent the targets, and the residents, students, or workers in a structure are evaluated as the receptors, or population. Now that we've established the basic scoring elements for evaluating an SSI site, let's look at how that information translates to a component score. The SSI component score sheet shown here should look familiar, as it includes the 3 factor categories evaluated, regardless of pathway. You can also see the factors evaluated within each factor category, some common to all pathways, some unique to the SSI component. The score sheet shows how to use the factor category values to get a component and pathway score. The score sheet can be thought of as a map for the HRS evaluation, and it will be referenced as we progress through the other modules. To make things a little easier to follow, this graphical representation of the score sheet will be used throughout the training to illustrate the scoring factors being discussed. These graphics identify the 3 factor categories, their associated factors, and the maximum values that may be assigned. The rest of this module focuses on the SSI component scoring structure, providing just enough information to give you a framework or context for the more detailed modules that follow. Let's move on to how we score an SSI site. The fundamental elements that serve as the basis for an HRS site evaluation are areas of observed exposure and areas of subsurface contamination. We typically refer to them using their acronyms, AOEs and ASCs. An AOE represents an area where contamination has been documented to have entered regularly occupied structures from the subsurface. An ASC represents an area with regularly occupied structures overlying subsurface contamination, but where the contamination has not yet been documented to have entered into the structure. AOEs and ASCs are similar to areas of observed contamination delineated in the soil exposure component. The figure here shows 2 distinct areas, one AOE, the area shown in orange, and one ASC, the area shown in green. We'll provide details on how these areas are established in Module 2. Okay, now let's turn our attention to each factor category and how they fit into an overall scoring of the SSI component. As we have previously discussed, the first factor category, likelihood of exposure, considers whether populations and structures are actually exposed to contamination or could be exposed. For scoring purposes, there are 2 options for assigning this factor category value. The first is to assign a score based on an observed exposure, which means someone from within the structure is exposed to actual contamination intruding from the subsurface. Assign a value of 550 for this factor category if you have documented an observed exposure. An observed exposure can be documented by either chemical analysis or direct observation. If an observed exposure is not documented at a site, the second option for assigning this factor category value is to assign a score based on the potential for exposure to contamination. The values assigned can range from 0 to 500 based on an evaluation of 4 factors. Okay, 1 factor category down, 2 to go. Now let's review the waste characteristics factor category. The waste characteristics factor category considers the most hazardous substance or substances and the amount of contamination at a site. The factors evaluated include toxicity, degradation, and hazardous waste quantity. The toxicity and degradation factors reflect the toxicity of a hazardous substance and the probability that it will degrade in the subsurface before intruding into a structure. These factors are combined together and can have a maximum possible value of 10,000. The hazardous waste quantity factor evaluates only the amount of contamination in the structures to which populations are exposed or likely to be exposed, and not the contamination in the subsurface. A maximum value of 1 million can be assigned to the hazardous waste quantity factor. The target factor category typically has the most impact on an HRS score and the SSI component is no different in this regard. This component evaluates three factors that make up the target's factor category value: exposed individual, population, and resources, which are shown in this figure. The exposed individual factor represents the maximally exposed individual and has a maximum value of 50. The population factor represents the receptors, or those people living, working, or attending school in regularly occupied structures within an AOE or an ASC. There is no maximum value for this factor. This component also evaluates a resources factor. If resources are present at an SSI site, then 5 points are assigned for the factor. Now that we've covered all three factor categories, there are two additional topics specific to the SSI component to review. The first is, what hazardous substances are eligible for consideration? For an HRS evaluation, regardless of pathway, we know that the hazardous substance or substances included in the evaluation must be a CERCLA hazardous substance, pollutant, or contaminant. However, additional criteria must be met for a hazardous substance to be eligible for an SSI component evaluation. That is, a hazardous substance must either meet observed exposure criteria or meet both observed release and certain volatility criteria, which are determined using a substance's vapor pressure and Henry's law constant value. Essentially, substances used to establish an AOE are eligible for consideration because they are documented to have intruded into a regularly occupied structure, whereas substances used to establish an ASC must be sufficiently volatile to potentially migrate through the subsurface and into overlying regularly occupied structures. Once the eligible substance is established for a site, it will be used in other parts of the evaluation to determine factor values such as toxicity and degradation in the waste characteristics factor category evaluation. The second topic is, why are regularly occupied structures important? The regularly occupied structure is the foundation of an SSI component assessment because this component evaluates the threat to populations within structures that are, or may be, exposed to subsurface intrusion contamination. Therefore, a structure needs to be regularly occupied to be included in an SSI evaluation. The HRS defines regularly occupied structures as the structures with enclosed airspace where people either reside, attend school or daycare, or work on a regular basis, or that were previously occupied but vacated due to a site-related hazardous substance or substances. The HRS also makes a distinction among structures based on whether or not the structure has subunits. A subunit is a partitioned area within a regularly occupied structure that has its own air exchange or HVAC system. For example, individual apartments in an apartment building are generally considered subunits since they have individual air exchange systems. The other modules will include details on how to evaluate regularly occupied structures and subunits in an SSI component evaluation. The other modules in this training segment will dive into the specific mechanics of how to evaluate an SSI site. They are organized based on the three HRS factor categories and will present the rule information, translate it, and then show how it is applied using a site scenario. This wraps up Module 1, an overview of the SSI component basics and scoring structure.